Hello 8th graders. In this IXL support video we're going to be taking a look at assignment F.5, which is called Exponents with Decimal and Fractional Bases. And by this point you understand an exponent, the positive ones at least, mean to multiply the base a bunch of times. But the challenge for S5 is your base won't be a whole number anymore. It's going to be either a fraction or decimal. So we need to remember how to multiply with our fractions or with our decimals. For this first one we're asked to evaluate 1 over 4 squared, or the fraction 1/4 squared. And what that really means when we have 1/4 squared is it's saying you need 2 copies of the fraction 1/4 to be multiplied together. So I could rewrite 1/4 squared as 1 over 4 times 1 over 4. And then I remember whenever I multiply with fractions, I just multiply the numerators together, top times top, which gives me 1. And I also multiply the denominators together. 4 times 4 gives me 16. So this tells me here that the answer for 1/4 squared must be 1 over 16. And the next problem that we see here, actually, they're being nice, the base is the same. They say 3 over 4 cubed. So I'm going to clean up the whiteboard a little bit quickly here. And we need to now do 3 over 4 cubed, which means we need to do 3 over 4, but 3 copies of that multiplied together. So I'm going to set that up here by writing 3 over 4, 3 copies of it, and multiplying this out. Now I see on the top I just have 3 copies of the 3 to multiply together. So 3 times 3, or 3 to the 3rd power, gives me 27. And on the bottom I see that there's also 3 copies of a 4. So I could rewrite that as 4 to the 3rd, or 4 times 4 times 4. And we see something important here. When I apply an exponent to a fraction, I could really just take that exponent and put it right onto the numerator, right on the denominator, and skip this whole middle step that I just did right here, if I realize that this exponent just gets applied to the numerator and denominator. 3 cubed is going to make 27, like we mentioned a second ago. And 4 cubed, 4 times 4 is 16. 16 times the last 4 gives us 64. So that tells us here, when we're doing this math out, 3/4 to the 3rd power, or 3/4 cubed, is 27 over 64. And no matter what happens with your fractions, we see they gave us another fraction here. For the next one, we've got 1 over 3 squared. And no matter what happens, you're just going to really apply that exponent to the numerator and denominator. So if I want, I could just rewrite 1 over 3 squared as 1 squared over 3 squared. And then I know that's going to be 1 over 9. I'm hopeful that they're going to start giving us some decimal examples, something else to work through, and we see that show up here for the first time. But the whole key with the fractions, and I should have had this up already, and sorry for the interruption there, but the whole key when we have a decimal raised to an exponent is going to be to remember kind of the same idea. This exponent just tells me how many copies of the base to multiply together. Or in this case, this is really saying I need to take 0.01, or 1/10, and multiply it together 4 times. And that's what we're showing you here on the screen right now. So this means I'm going to have to be comfortable multiplying with decimals if we've got a repeated decimal multiplication problem. So I'm going to switch my pen color over to purple and start thinking about how do I multiply 0.1, or 1/10, with another 0.1. And there's a couple ways to think about this. The main way, I like to leave it as a decimal. I'm comfortable multiplying with decimals, and we're going to show you how to do that right now. So 0.1 times 0.1, if I multiply with decimals, I first kind of ignore the decimal point. I know that 1 times 1 would give me 1. But if this were really 1 times 1, we would have needed 1 extra copy of 10 here to move the decimal point, and we would have needed 1 extra copy of 10 here to move the decimal point, or we'd need to move the decimal point twice to the right. So to account for that, I need to move my decimal twice to the left here. It's not going to be 1, I'm going to slide a decimal to 0.1 and 0.01. And what we start to see is you can count up the number of places after each factor's decimal point. One of them, another one of them is 2, and your answer should have that many places after its decimal point. Now I need to keep multiplying by 1/10, or 0.1, so I'm going to do that again. 1/10 times 1/100th, or 0.01. I'm going to just multiply the 1 times 1 first. And now I see this needed 2 copies of 10, and this only needed 1 copy of 10 multiplied. So I'm going to need to take 3 powers of 10 away from this answer, or 1, 2, 3. So our answer at this point is 0.001. And you can see there were 3 places here after the decimal, and I have 3 places after this one. One final time we're going to multiply by 1/10, and you see this decimal just kind of keeps sliding left each time we're multiplying by 0.1. Maybe a trick you see. So when I multiply the last time by 1/10, 0.001 times 1/10, I'm going to still get a 1, but this time I'm going to need 4 places, 1, 2, 3, 4. 4 places of numbers after the decimal point. So our answer here is 0.0001. That's the same thing as 1/10,000 if you wanted to get fancy pronouncing that. And we're going to show 1 or 2 decimal ones just to re-teach or get a hang of this algorithm. Again, as you see, they're a little annoying. Sometimes they make you multiply to the power of 4, power of 5, and that's just causing us to do some more work. So here I'm going to set up my 2/10 times 2/10, and I'm going to pause right now. I'm going to switch my color. I could start multiplying this out with the algorithm 2/10 times 2/10. Or, as you see me calling this 2/10, I could recognize that 0.2 is the same thing as 2 over 10. We pronounce 0.2 as 2/10. So one option always in this lesson is, if you're struggling with multiplying decimals, is if you can convert them to a fraction, then we already know the fractions are a bit easier. We would just do 2 to the 4th power over 10 to the 4th power. And that would perhaps be a quicker and easier way for some of you to work this problem out. 2 to the 4th, figure out what 10 to the 4th is, there's the fraction for your answer. I'm going to keep going with the decimal form because I think we should be comfortable with both fractions and decimals in multiplication. 2 times 2 is going to give us 4. Remember, ignore the decimal at first, just multiply as if the decimals were all the way at the end. And now recognize we would have needed to use 2 powers of 10 to move 2 decimal points, each of them 1 place to the right. So I'm going to take those 2 powers of 10 back by moving the decimal point 2 to the left, or 0.04. And that's what you'd get with 2/10 times 2/10. You'd get 4 over 100, or 4 100ths, as we see here. Multiply by 0.2 again. 2 times 4 is 8, and this time we have 3 places, 1, 2, 3 after the decimal, so I'm going to put 2 zeros, so that when I put my decimal point, I have 0.008, or 3 digits after my decimal point, just like we see the 3 digits after these 2 factors. For the final time, we multiply by 0.2. 2 times 8 is going to give us 16. So we multiply 8 thousandths by 0.2, or 2/10. We get 16, and now I see 4 places, so I'm going to need a 0, 0, 2 zeros before my decimal point. And just to pull everything together from this assignment here, if you had done 2 squared over 10 to the 4th, you would have been getting you would have been getting 16 when you do 2 to the 4th, and you would have been getting 10,000 when you do 10 to the 4th. I can't really fit that 10,000 there. We're going to call it 10K for 10,000. And 16 over 10,000 is the same thing as saying 16 10,000ths, or 0.0016. I'm curious if they're going to take the fraction, so I'm going to put 16 over 10,000 here, but I think they're going to mark me wrong because they like you to simplify usually. Yeah, they're going to make me put in a full number answer. So you see, they said the correct answer is 0.0016. If I did do 16 divided by 10,000, I'd be okay there, but it does look like here for IXL, if they give you the decimals, they're not going to be nice. They don't let you put your answer in as a fraction. If it started as a decimal, they make you put the answer in as a decimal. So you see here some of their proof, their explanation, how they did 0.2 times 0.2 times 0.2 times 0.2, and they get to 0.0016, just like I had. But be careful, if they're giving you a decimal base, they want a decimal answer, not the fraction. We're going to show one final example, just to kind of clean this up, and I know this video went long. If you're still watching us, we don't think you need to be, but one more example if you need to see decimals multiplied together. So here we have 1/10 times 1/10. And if I use my algorithm for multiplying decimals, 1 times 1 is 1. And I see 2 digits or 2 places after the factor's decimal points. So I need 2 digits after mine. I get 0.01. Also here we could have recognized 0.1 is really just a fraction, 1 over 10. 0.1 is the same thing as 1/10. And I could have done 1/10 times 1/10 to to get 1 over 100. But then again, here, the way IXL does this, I'd have to switch 1 over 100 to its decimal form. That's 1 penny, or 1/100th of a dollar. So I'd need to switch that to 0.01. So 2 different options to get to our correct answer. Multiplying with decimals can be challenging. If you do have any questions as you're working on F5, I'm happy to work with you, talk through some. My email address, as always, we'll put that on the board. That's ddoherty3@bostonpublicschools.org. Thanks for watching to the end of the video. Thanks for working hard on a tough assignment for IXL.